Okay, so let's talk about nomenclature. This is the first worksheet of the new unit. And the first thing I want to talk about is naming ionic compounds, which is type 1. So when we are naming ionic compounds, these are typically binary, which means there's only two atoms or two types of atoms. And one is going to be the cation, which is always first. And the second is going to be the anion, which is always second. And the cation is positively charged. The anion is negatively charged. And the sum of those two charges has to equal 0. It's got to be a neutral compound. This is the easiest type of naming. That's why it's 1. And so ionic naming, we're just going to name the cation with its name. So for the cation, there's no change. For the anion, however, we change the ending to IDE. So if I had something like NaCl, I would name that sodium for the cation and chloride for the anion, because chlorine, this ending is going to change to IDE. Fairly straightforward. Right now we're just talking about naming compounds. I'm going to come back. Well, I think I'll go ahead and tell you how to write the formulas, because there's two skills, naming and writing formulas. And I already gave you a clue here, is that we have to have it add up to 0. So you'll find in Quizlet, there's a huge set of ions that I need you to know. And I know that's disappointing, but some of you memorize well, and that will make you very happy. Some of you will have to struggle and work a little harder. So when I have a name, let's say I have something like calcium fluoride. I know since this ends in IDE that it's going to be the element with a negative charge. So I'm going to be looking at fluorine, and I have to have memorized its charge, which is a -1. Then calcium, I know, is just going to be calcium. And based on its position in the periodic table, I know that it has a +2 charge. And so for every 1 calcium, I'm going to need 2 fluorines to make it add up to 0. And so it would be CaF2. I need 2 of these for one of these. Gives me a total of -2 charge, +2 charge. And that would be my final answer. When writing these, or trying to write a formula from a name, I strongly urge you to write out the 2 ions involved and then figure out how many you need of each before you go on. So we will talk about this a lot in class too, so don't worry if it doesn't seem very clear right now. Type 2 is naming ionic compounds where we have a variable charge cation. So that would be something where we have 2 ionic with a transition metal. And transition metals, because we're filling d electrons, they have a lot of very strange things going on. They will have things like possibly 2 different ions are possible for some of these. So, and you also have these listed in that set that I just mentioned. So if I have something, and so these require a Roman numeral. And that Roman numeral is equal to the charge on the cation. So if I have something like copper to, let's say oxide, this tells me what charge I'm supposed to use. So in certain regards, these are really easy. I have to know the symbol for copper, which is Cu. I know it's going to have a +2 charge. Now I look at oxide. Oxide is O2 minus. So 1 copper to 1 oxygen will get me a new compound, neutral compound, and so it'd be CuO. If I give you a formula that has a transition metal, it often requires a Roman numeral, so you have to figure out the charge. Let's say I gave you something like PbO2. So I know Pb is going to require some kind of Roman numeral. It's one of my transition metals. Oxygen always has a -2 charge, and so I have to figure out what the charge is up here on lead. So let's use a little algebra. I have 1 lead that I don't know the charge of, and I have 2 oxygens I know are -2, and all compounds add up to 0. So now I can figure out the charge on X. So X minus 4 equals 0, so X equals +4. So that tells me the Roman numeral here. So this would be lead 4. That doesn't look like a 4. IV. And that goes in parentheses, and then oxide. So that's 2 of the ones you need to know. The next one is 2 nonmetals. Oh, I did not mention something else. Let me grab another sheet of paper. Let's talk about some of our compounds don't just have 2 elements possible. So here I talked about just binary, but sometimes we have polyatomic ions. And polyatomic ions mean that I have more than 2 elements present that make up an ion. An example of that would be something like SO4 2-, which is a sulfate ion. The sulfate ion stays together exactly the way it is. So if I wanted to do sodium sulfate, I would first want to write my 2 ions. So sulfate is SO4 2-, sodium is Na+. So to make this equal 0, I'm going to need 2 sodiums for 1 sulfate. So it'll be Na2SO4. Let's say I have a name. Let's say I have something like barium nitrate. So I would have to write out this ion and write out this ion. And so barium would be Ba2+. Nitrate is NO3 -1. I'm going to need 2 of these units. So I need to put that in parentheses. So I'm going to have Ba parentheses NO3 parentheses. And I need 2 of them, so I put a subscript 2. What if I give you a name, something like, or I give you a formula. Let's say I give you something like CaCO3. Now you have to give me the name. You'd name this one calcium. You'll name this one carbonate. That's not too difficult. We don't care what the subscripts are, except for when we're naming this ion. So we've talked about ionic compounds. We've talked about ionic compounds with variable charges for the cation. And now we're going to go to the third type, which is when we have 2 nonmetals. That would be something like CO2. We have to have some rules for this. We'll have to have something like whenever we have more than one of something, we're going to use some prefixes. And so 1 would be mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. These should start to sound familiar because these are coming from geometry, right? 7 is hepta, 8 is octa, and 9 would be nona, and 10 would be deca. We rarely see these higher ones, but it is possible. So in this case, we have 1 carbon, but we never use mono with the first element. Never use it with the first element. So this would be carbon. And since I have 2 oxygens, it'll be dioxide. To distinguish it from this compound, which is carbon monoxide. If you get 2 of the same letters together, you typically drop 1. So these, I think, are easy when you have the name to write the formula because I'm telling you exactly how many to put where. So if I had something like P4O10, I said these were rare. I didn't say they were never heard of. If I gave you the name, it would be tetraphosphorus decoxide. Decoxide, sorry. What if I gave you something like N2O3? Or let's see, I've done enough where I've written the formula and written out the name. What if I give you the name, which I think is fairly simple, and you have to write the formula? Nitrogen, let's do trioxide. So nitrogen would be N, 3 oxygens. Pretty straightforward, I think. I'll have another video on naming acids and bases, and we'll talk about these special cases of hydrates later. I hope this helps. We will be talking about this in class as well. Thanks.